In this tutorial, we're going to use Blender's physics engine to create a short domino run animation. We're going to add very simple lighting and materials and render it out in Eevee. As always, my keyboard shortcuts will be showing in the bottom right corner of my screen. The first thing I'm going to do is press A to select all the default objects and delete them. I will then create a plane by pressing Shift A and selecting Plane. This plane will become a stage for our domino run. With the plane selected, I will tab into the edit mode and then press S5 and enter for a 5x scale on the x-axis. Then I'll repeat the procedure for the y-axis, but this time I'll scale it 20x. For the floor finish, let's create the rear wall. I'm going to press 2 for edge select, followed by E, Z, and 10 to extrude the edge 10 meters up on the z-axis. Then I'll add a bit of a bevel by pressing Ctrl B and scrolling my mouse wheel up to add 3 or 4 segments. I can then tab out of the edit mode, right click on my stage and select Shade Smooth. And we're done modeling the stage. Now I've decided that my domino run will be triggered by a rolling marble, so let's create one. I'm going to press Shift A and select UV Sphere. Then in the Add UV Sphere menu, I'm going to set the radius to 8 centimeters. I find that simulating small objects like dominoes and marbles at their real size causes the physics to become unstable. So I'm going with the convention of multiplying all the sizes and weights by 10. Now let's zoom in on the marble. Press G for move, Z for Z-axis, and move it up a little bit. Then I'm going to right click on it to shade it smooth. And it's finally time to start with the physics. I'm going to open the Physics Properties tab and select Rigid Body. I'm going to leave almost all of its settings as they are, except the weight, which I'm going to set to 50 grams, and the shape, which I'm going to change to sphere. Primitive shapes such as the sphere and cylinder result in better stability and performance than mesh and convex hull, so I prefer using them whenever I can. Now, before I forget, I'm going to set up the parameters of my entire simulation. So I'm going to go to the Scene tab and see that the rigid body world was automatically created for me. To improve the stability of my simulation, I'm going to change the steps per second to 300 and solver iterations to 50. Note that these values are not from some manual. I actually found them through a little bit of experimentation. Those may need to be different if you have more objects in the scene or if your objects are much larger or smaller. And finally, I'm going to set the maximum duration of our simulation to 400 frames. Then I'm going to go to the Output Properties tab and set my frame rate to 30 frames per second. With all of this out of the way, I want to give my physics simulation a bit of a test. I'm going to press spacebar to start the simulation and oops, let's press spacebar again to stop it. Looks like I forgot to add a rigid body to the stage and the marble has nothing to collide with. With the stage selected, let's go back to the Physics tab and add one. Since I don't want the stage to move, I'm going to set the type to passive. And since the shape of the stage does not match any of the primitives, I'm going to set the collision shape to mesh. Now let's move the playhead back to frame 0 and try to replay the animation. Looks like this time it works the way we need it to. So let's go ahead and create our first domino. After creating a cube primitive, I'm going to tab into the edit mode and press G, Z, and 1 to move the cube 1 meter on the z-axis. I will then tab out of the edit mode and set the dimensions of the domino. As per my convention, I will use the real dimensions I found online multiplied by 10. Next, with my domino still selected, I'm going to press Ctrl A and apply Scale. Then I'm going to right click on the domino and set Origin to Geometry. I do that to make sure that the physics engine has no confusion about the dimensions or the center of mass of my domino. I'm also noticing that I left the playhead at frame 40. Before we proceed, let's set it back to 0. With all of this out of the way, we can enable rigid body for our domino, keeping the type active and setting the mass to 80 grams. And after I set the collision shape to box, I am finally ready to run the simulation. And the domino seems to be jumping up by itself. Luckily, this is easy to fix. To do that, we're going to expand sensitivity and set the collision margin to 0. I will also repeat it for the marble and for the stage as well. Now let's rerun the simulation. It's not very exciting yet, but otherwise it's working. Now we're much closer to seeing the actual domino effect. First, let's create some more domino pieces. To do that, we could copy and paste, but there's a better way. Let's select our domino and go over to the Modifiers tab. In the Add Modifier menu, let's select Array, and the settings will turn off Relative Offset, and instead enable Constant Offset. Let's set its value to 40 centimeters on the y-axis, and then set the count to 10. And now, after we apply the modifier, we're going to end up with the desired 10 pieces. The only problem is they're all a single object. So let's tab into the edit mode, press P, and separate them by loose parts. Then we'll tab out of the edit mode, right click on any one of the selected dominoes, and select Origin to Geometry. And here we have it, 10 domino pieces with identical rigid body settings. Let's give our physics simulation a try. I think to get the desired result, we need the marble to fall a tad to the left. To make moving things easier, let's enable the Move gizmo, give the marble a bit of a nudge, and rerun the physics simulation. Perfect, exactly what we need. Now, why don't we make our next batch of dominoes run up steps? I guess let's create some steps first. Actually, let's create our steps out of dominoes themselves. I'm going to duplicate the rightmost domino and right click to keep it in place. Then I'm going to type in RX90 followed by RZ90 followed by Ctrl A to apply rotation. Then in the physics settings, I'm going to change rigid body type from active to passive. Now with the numpad 3, I'm going to switch to right orthographic view and position the step. And after it's done, I'm going to use the array modifier to create the rest of the steps. In the modifier settings, I will disable the relative offset, enable constant offset, set the y distance to 0.3, and z distance to 0.15. Finally, I will set the count to 10 and apply the modifier. Just like my dominoes before, I don't want my steps to be all one object, so I'm going to tab into the edit mode, press P, and separate them by loose parts. And finally, tabbing out of the edit mode, I will right click any one of the steps and set origin to geometry. And my steps are now ready to receive the next batch of dominoes. Let's start by copying the rightmost domino and placing it roughly about the center of the first step. Then I'm going to go to the snapping options and enable the snapping of edge center to object center. Now if I grab the y-axis of the gizmo and hover over the edge of the step, the horizontal centers of both will become aligned. Next, let us place the domino on the step. I'm going to go back to snapping options, enable snap with closest, and drag the Z handle towards the step until I get a snap. The process for creating the rest of the dominoes is essentially the same as for the steps themselves, so I'm just going to go through it without commenting every step. And here we have 10 more dominoes, each precisely positioned in the middle of its own step. Let's run the physics simulation to try it out. Well, this is exactly the effect I was going for. Now instead of dropping the marble from mid-air, how about having it go down the slide? To start working on the slide, I'm going to press numpad 7 to switch to the top view and add a plane. I will scale the plane to about twice the width of the marble, and then scale it 8x on the y-axis. I will then tab into the edit mode and press Ctrl R to split the plane down the middle. Then I will bevel the edge to about the width of the marble, tab out of the edit mode, and move the plane closer to its final position. I will then go back into the edit mode and push the middle two edges down to form a trough shape. Lastly, I'm going to smooth the shape out by slightly beveling the inner edges. Then I'll tab out of the edit mode, set the shading to smooth, apply scale, and tilt it towards the first domino. Now all that's left is adding a rigid body with the type set to passive, collision shape set to mesh, and a zero margin. And finally, with all of those things out of the way, it's time to try out the simulation. Looks like everything's behaving like we expect it to, which means we're done with the functional part. With the physics running smoothly, the second part of this tutorial will be dedicated to the presentation. The first thing we're going to work on is the slide. We're going to turn it from a piece of geometry hanging in midair into something that resembles a physical object. First, I'm going to go to the Modifiers tab and give it a Solidify modifier. And in the modifier settings, I'm going to set the thickness to 5 centimeters. And now that it's got some thickness, I'm going to bevel it with the Bevel modifier. In this modifier settings, I'm going to set the thickness to 1 centimeter and the number of segments to 2. After you do that, you may realize that the beveling got applied to the inner edges as well. To prevent that, I'm going to set the modifier's limit method to angle. The default 30 degrees works well in my case. And now that I'm happy with the results, I'm going to go ahead and apply both modifiers. Now let's give our slide some legs to stand on. I'm going to tab into the edit mode, press Ctrl R to create an edge loop down the middle, and Ctrl B to split it in two by beveling it. I will then select this edge over here and duplicate it. I'll separate it by pressing P and choosing Selection. I can now tab out of the slide, select the new edge object, tab into the edit mode again, and press 1 for vertex select mode. I will then switch to side view, select the vertex on the left, and extrude it down all the way to the floor. Let's repeat the same procedure for the vertex on the right. With the basic outline ready, I'm going to press 2 to switch to edge select mode, then A to select all, followed by E and X to extrude the shape on the x-axis. I will then press 3 for face select mode, A to select all, then Alt E, and extrude faces along normals. After giving the legs some thickness, I'll go back to edge select and taper the legs in where they touch the floor. Next, I'm going to select all edges and give them a small bevel. Then let's tweak the positioning a little bit to make sure that the legs are attached to the slide. Tab out of the edit mode and add a mirror modifier to create the legs on the other side of the slide. Now let's set the shading to smooth and our slide model is complete. Now let's do something similar for the steps. First, I'm going to select the bottom step and tab into the edit mode. Then I will add an edge loop in the middle. Select and duplicate the side edge and press P to separate it by selection. I can now tab out of the edit mode, select the newly separated edge, and remove the rigid body it inherited from the step that it was a part of. With the edge selected, I'm going to tab into the edit mode and select the edge again. Go to the side view and make sure the snapping to edge center is enabled. I will then hover over the top edge of the last step and press E to extrude. Then I'll disable the snapping and add an edge loop to the newly created shape. I will slide that loop close to the bottom end. Now let's zoom in this area. Select this short edge over here and press E and Z to extrude it downwards. Now let's straighten out this part over here. To do that, I'm going to press S, Z, and 0 and drag the flat face down to level it with the floor. Then I'm going to switch to vertex mode and move the inner vertex to the left a little bit. Now that we have our short leg, let's work on the long one. To start, I'm going to extrude this edge on the y-axis a little bit. And then extrude the resulting bottom edge on the z-axis until it meets the floor. Then I'll switch to the vertex mode and bring the inner vertex to the right a little bit. Now that we have the general shape, let's give it some volume. I'm going to press 3 for face select, A to select all faces, and E to extrude it sideways. All that's left to do is to give it a slight bevel, enable smooth shading, and duplicate it to the other side with the mirror modifier. Looks like we're close to being done with modeling. But before I call it done, I want to review it one more time. First, I'm going to go to the Output tab and set the duration of my animation to 300 frames. This is just to make sure I have enough time for all my dominoes to fall. And with that step done, let's run the simulation. I'm pretty happy with how it went, except for the very ending. There's one more detail I'd like to add to the end, which would make the whole animation more complete. I'm talking specifically about this last domino over here. I think this whole setup will feel more intentional if the last domino falls in a little cup. So let's go ahead and add that last detail. First, I'm going to add a cylinder. Then in the edit mode, I'm going to select the bottom face and press G, Z, and 1 to move it 1 meter up. Then tabbing out of the edit mode, I'm going to press S and 0.5. This will make it half the size. Next, I want to move it to the position where I want my cup to be. Tab into the edit mode once again. Select the top face and inset it a little bit. Then I will switch to side view and enable wireframe shading. Then to create the inner volume of my cup, I'm going to extrude the selection inwards. When I'm done with that, I'm going to switch to edge select mode, hold down Alt and Shift, and loop select the edges along the bottom of the cup. With both selections active, I'm going to press S, followed by Shift Z to scale on all axes except Z. The basic shape of the cup is now done, and I can switch back to solid shading. Next, while holding down Alt and Shift, I'm going to loop select the inner and outer rim of the cup, and give all of the selected edges a slight bevel. At this point, the modeling of the cup is complete, so I can tab out of the edit mode and give it smooth shading. And since I'm going to use it in the physics simulation, I'm going to apply scale. I am now ready to go to the physics tab and assign a rigid body. Since the cup is not going to move, it's going to be a passive type, and I'm going to set the collision shape to mesh. Lastly, I will set the margin to 0 and run the simulation. Yep, that looks much better. Now that we're done with the modeling and simulation, we're finally ready to work on lighting and materials. I'm going to start by bringing the playhead back to frame 0 and enabling material preview. First, let's create a material for the background. So with the background object selected, I'm going to go to the Materials Properties tab and create a new material called BG for background. For the base color, I'm going to paste a pre-picked hex value. I'm also going to remove specular highlight and set roughness to 1. The next material will be for the slide. With it selected, I'm going to press New, name the material Slide, and paste my pre-selected color value. To give it somewhat of a shiny plastic look, I will set its roughness to 0.1. My next material will be shared by a few objects. The marble will be one of them, so I'm going to select it. Click New in the Materials tab and call it Metal. Just like with the other materials, I'm going to paste the pre-selected color, dial the metallic property all the way up, and set roughness to 0.1. Then I'm going to go ahead and assign it to all the objects I want to share this material. Next, we'll create a material for the cup. I'm going to make it a bit less shiny by giving it a roughness value of 0.3. Now let's work on the step material. We're going to select the bottommost step and create a material pretty similar to the other ones we've already created. Except in this case, I also want to soften the edges using the bevel modifier. I'm going to set the amount of 1 centimeter and a number of segments to 3. Now, how do I apply the same changes to the other steps? Well, let's start by selecting them all, starting from the very top, and making sure that the last step, the one that has the desired changes, gets to be the last one I select. Once I'm at that point, I'm going to press Ctrl L, and in the Make Links menu, select Modifiers. I will then repeat the same process for materials, and at this point the steps are done. I am going to apply the exact same approach to the dominoes, so to save time I'm going to do a bit of a time lapse. And now that we're done with the materials, let's set up some lights. First, I'm going to change my viewport shading to rendered. Then in the world properties, I'm going to set color to environment texture. I'm going to use a texture that ships with Blender itself. Once I press open, I'm going to navigate to Forest EXR in Blender's own installation directory. And once I have it selected, I'm going to have this nice ambient light in my scene. Next, I'll add an area light. I am going to position it around the center of my domino run and make it about the same width. Then I'll go to my lights properties and set its power to 1000. Next, I'm going to move it slightly above the scene and rotate it towards it on the y-axis. At this point, I'm pretty happy with my lighting and I'll consider it done. The last thing we're going to create is a camera we're going to use to render the animation. So I'm going to switch to right orthographic view, press Shift A and select camera. Then I'm going to move the camera to around the center of my scene and create a dedicated 3D viewport for it so that I know what the camera sees as I'm moving it around. So I'm going to drag the little rounded corner up and under editor type, select 3D viewport. Then I'm going to move the cursor over the new viewport and press numpad 0 to get the camera view. I'm also going to press Z and select rendered. Looks like I forgot to turn on smooth shading for my dominoes, but I think at this scale it's not going to be too noticeable. And now that I know what my camera sees, I'm going to use my main viewport to drag the camera around to its final position. I'm going to position it so that all the dominoes standing on the floor make it into the viewport. Then I'm going to raise it up a little bit and tilt it down by rotating it on the y-axis. Now let's make our camera actually follow the rolling marble and the falling dominoes. First I'm going to open the Scene tab and scroll down to Rigid Body World Settings. As I was working in my simulation, I started to realize that everything's a bit too slow. Luckily my Rigid Body World has a speed setting, so I'm just going to double the simulation speed. After that I'm going to scroll down and click on Bake All Dynamics. This is going to pre-calculate and save the entire physics simulation making sure the result is the same every time I press play, and freeing up resources for things like rendering. Now you can see it baked 400 frames, which is more than I need, but the overhead is so low that I'm not going to bother changing it. Now, as a result of that, I can just play my pre-recorded simulation back and forth by dragging the playhead. With all of that out of the way, it's finally time to animate the camera. First, I'm going to change transform orientation from global to local. I find that rotating the camera in local context is a lot easier. Do note the change in the axis orientation here. And now I'm going to rotate the camera on the y-axis until the slide is in the middle of my camera view. Once I'm happy with the camera view, I'm going to press I for insert keyframe and select rotation as it's the only thing I'm going to animate. Then I'm going to find a frame where the last domino is starting to fall into the cup, and with the playhead in that frame, I'm going to rotate my camera on the Y and X axis until I'm happy with what I'm seeing in the camera view. Then I will press I again and insert another rotation keyframe. Now if I drag the playhead back and forth, I should see the dominoes falling and the camera following the action. Now the last thing I'm going to do is kind of unnecessary, but I think it adds some character to the animation. I'm going to select the very last domino, go to the Materials tab, and change its materials from dominoes to slide. And now I feel that my scene is complete and I'm ready to proceed to rendering. Before I go into the render settings, I am going to dim my area light, which I now realize is a bit too bright. So in the light settings, I'm going to take the power down to about 300. Now, having adjusted that, I'm going to go to the Render Properties tab, make sure that my rendering engine is set to Eevee, and enable Ambient Occlusion and Bloom. Under Bloom, I'm going to set the radius to 3. Other important settings are Screen Space Reflections and Motion Blur. And finally, under Color Management, I'm going to change the look to medium high contrast. After that, I'm going to proceed to the Output tab, where I'm going to keep the resolution as it is, and set the end frame to 130, since no action can really be seen after that frame. Then I'm going to set the output directory and the name of the file. Yes, that part after the slash there is actually the name of the file. Then under the file format, I'm going to pick FFmpeg video. And finally, under encoding, I'm going to set the container to MPEG-4. I'm going to keep the rest of the settings as they are, go to the render menu, and select render animation. Now, Eevee is a very fast rendering engine, but it's still going to take a few minutes, so I'm just going to speed this up. And at frame 130, we're finally done. Well, if you made it this far, I really admire your perseverance. I really hope this tutorial was useful to you and you got the result you're happy with. I'm always really grateful for the feedback in the comments. And if you want more of these tutorials, please consider liking and subscribing. See you next time.